Hello, my name is Liza Maria, and today on my podcast, I'm glad to have George Salazar, which worked for NASA as an engineer, and he has over 40 years of experience in communication, speech control, and systems engineering. Hello, Mr. Salazar. How are you doing today?
I'm good, Elisa. How are you doing?
I'm doing great.
Great.
So to start this podcast, can you tell us more about your career working with space?
Wow, I mean, there's a lot of them that I worked at. My area was human spaceflight. NASA is made up of different organizations that do different things. You got unmanned, you got robotic missions, and a human spaceflight. So my area was human spaceflight. I worked at the Johnson Space Center, and I started off with the shuttle program. And I first started with working the what they call the modular auxiliary data system, and that was the data acquisition system on the shuttle that acquired engineering data from somewhere in a vicinity of 2,500 sensors on the space shuttle. That information was recorded on the mass recorder, and it was brought down to Earth. When the shuttle returned, we would remove the recorder tape. At that time, it was a tape, and then it became a solid state recording devices. And we would take the data out of those recorder, and then we would give it to the engineering community. My responsibility was making sure that everything was working properly. We got the data, we would send it to the engineers. As far as studying the structure of the space shuttle. Later on Space Shuttle, I got involved with the cockpit avionics upgrade, which basically entailed improving the amount of data that was available to the astronauts on the 11 displays that they had on the Space Shuttle. That project involved over 200 engineers, including myself. It was quite challenging, but a great project in terms of dealing with all kinds of people, and also with different companies. There was a lot of companies involved in that project. Another one that I was involved with the Expert X-38. I was responsible for the flight data systems, and so it was a combination of flight data systems that encompassed not just the hardware but also software. And I got involved with Draper Labs, who was supplying what they call fault-tolerant parallel processing. So my first introduction to the whole area of fault-tolerant computing on a spacecraft, it opened my eyes to more of systems engineering. In fact, that project actually helped me figure out what I wanted to do when I grew up, so to speak, advanced degree. That's why I went back and got my systems engineering, master's in systems engineering. The other areas that I worked space on at NASA was also the International Space Station, the audio system. That was quite challenging, just simply because of the things that kept changing as far as requirements are concerned. I started to learn how requirements can mess up a project or improve a project. You can look at it both ways. But I have to say, for the most part, the audio system came out well on the International Space Station. Fast forward, I was involved with numerous projects, research projects. I don't think there's enough time to talk on. But the next major project that I became involved with was the commercial crew program with SpaceX as well as Boeing. More so on the SpaceX side, I helped work on the development of the touchscreen technology that's used on Dragon. Fast forward, I started working the commercial crew program. That was the first program actually that NASA got involved with commercial partners in order to develop a replacement for the space shuttle. So SpaceX, I worked mostly with, to some extent, with the Boeing system. But on SpaceX, my primary responsibility was working with the SpaceX engineers in developing the touchscreen display system that they had. It was kind of revolutionary in terms of spacecraft control. And so instead of using what traditionally spacecraft use tactile switches, they use touchscreen technology. Now, we had to be cautious about that because touchscreen technology was fairly new. We had to be careful about dealing with false touches and things of that sort that would cause inadvertent commanding of a spacecraft. So the way it worked out, working with safety people, reliability, and all that, is that the control of the spacecraft was split up into basically two pieces. The display technology was used for what we call benign commanding, turning lights on and off, fans, and audio, raising the audio levels, and things of that sort. Right below the touchscreen technology was a control panel. There was basically 33 switches that were used for critical commanding. And these were tactile. These were, somewhat what you call traditional commanding of a spacecraft. And so these critical commands, like for example, turning on a rocket motor and things of that sort, were a arm and fire type commanding. So you basically enable the command. Let's say, for example, to deploy a parachute, that's a critical command. So first you enable that, deploy the parachute, but then you had to press another button called execute in order for deploying that parachute. So that way there was making sure that you didn't incorrectly choose that command. So the whole display system of the Dragon was designed, to avoid incorrect commanding, if you will. So I spent quite a bit, a few years in that, and then I started to get involved with the human lander system for the Artemis program. The Artemis program is basically NASA's program for returning to the moon, but this time to stay, as opposed to back in the Apollo era, was just to go to the moon and then come back. Total time spent on the moon with the Apollo space program was 3.5 days. There were 12 astronauts that walked on the moon, but total time again was only 3.5 days. And this time, the Artemis mission, the intention was to basically go back to the moon, but now learn how to live and operate on another planet. So my involvement there was with the human lander system, and again, SpaceX, because they won the contract for that. I became involved with the human lander system for, with SpaceX, especially the displays and controls. And then later, Blue Origin won another contract, and so we also had Blue Origin. So now you had two contractors, Blue Origin and SpaceX, and it's a way of making sure that if one can't build a system, that the other system will be ready. And that's how we did Commercial Crew. SpaceX Dragon basically beat out, at least initially, the Boeing system. And it was a good thing that we had that competition. So the human lander system, much more challenging. The whole aspect of trying to land a Starship on the moon is a big challenge. Again, I was involved with the crew displays, but all kinds of challenges in terms of trying to land basically the Starship is a 10-story high spacecraft. Never landed something that huge on the moon. So in the last episode before I retired was dealing with things like moon dust plumes when the rocket's landing, dealing with the effects on electronics, and so there's still a lot of challenges that have to be overcome before we go back to the moon. But we're making progress there. That's basically, in a nutshell, in terms of some of my space experiences. I do have to say that another part that I actually enjoyed somewhat more was doing education outreach. I reached out to somewhere in the vicinity of 20,000 students in the lifetime that I worked at NASA. And I went from anywhere from elementary school, doing science experiments, all the way to universities and doing research projects that were looking at NASA technology for future space missions. So I kind of covered the whole gamut in terms of education outreach, which I enjoy, and I still do that to some extent.
That's awesome. And also, as someone that worked with space and at NASA, as you mentioned, how do you see the space exploration in the near future?
Well, I mean, space exploration in the near future. So you have, let's say, different types of missions, for space exploration. First, you got the unmanned space exploration, robotic missions, sending robots to Mars. And just recently, they're going to be, I think they launched the Clipper and so there's these what you call robotic missions that are going out there and exploring. And the way NASA looks at missions is first you got the scouts. So you think about like the old Wild Wild West in the United States, they would send scouts out to look at the land up ahead before what they call the wagon train with the people that were moving to the west of the United States. Before they would go forward, they would wait and see, okay, the scouts would say, this is dangerous, there's no water here, and things of that sort. So that would give them an idea, should we go that direction or should we move? Same thing with robotic missions. Robotic missions is to explore what potentially are some hazards, for humans if they're going to go to that particular planet or asteroid or moon. So the space exploration is moving out in two directions. One is unmanned or robotic missions, and then the other one is the human spaceflight. And of course, the human spaceflight is moving just a little bit slower than space exploration, but it takes both in order to come up with the whole concept of space exploration. Now, robotic missions, let me just be clear that there's two pieces to robotic missions. One is where they go specifically to a planet or asteroid or moon, but then there's also the flybys. You think about Voyager 1, Voyager 2, those are flyby robotic missions where they just go by, take photographs of the moon or the planet or whatever, and they keep going. Right now, Voyager 1 and Voyager 2 have already gone outside of the solar system. And they're still exploring. We're still getting data. Granted, it's not a whole lot of data, slow data, but we're still getting data. But space exploration, I think it's very exciting. I think the good part about exploration in the future is the participation of commercial companies, SpaceX, Blue Origin. Here in Texas, we have one called Firefly that's up and coming. We have Sierra Nevada that's building they call it a lift body spacecraft. So there's a lot of exciting opportunities for commercial companies to participate in space exploration. I know in the Artemis program, there's what they call the Commercial Lander Program that helps or is funding commercial companies to come up with some ideas of landing things on the moon, to learn more about certain technologies. One critical one is what they call in situ resource utilization, which basically they'll take soil from let's say the moon or Mars, put it into this machine. I'm saying this simplistically. They put it into the machine and out comes water and fuel for the rockets. But that technology is pretty young. They call it the low technology readiness level, or TLL. But the only way to get there is by developing, testing, and evaluating, and then going back and reevaluating again. I think lots of opportunities in space exploration, not just for NASA, but also for the commercial sector, and more so for international partners, different countries that are signing the Artemis Accord to participate in this huge adventure of learning to live on another planet in preparation for eventually one day going to Mars.
So also, as one of my questions here is, did you work with other engineers helping to build the space shuttle or other space missions?
Did I help with the space shuttle and other space missions?
Yes.
Yeah, I mean, on space shuttle, I actually started on, they call them STS, Space Transportation System missions. And so I started out with STS-7 and working that project. Actually, that was the mission with the first female astronaut on the American side ever launched into space, Sally Ride. And so, there's a whole bunch of things that I was involved with the space shuttle. There was some investigative work on space shuttle, trying to understand the aerodynamics of the space shuttle. So a lot of the sensors for what I called earlier the modular auxiliary data system, some of the sensors that I was responsible for, they were called pressure sensors. They were located underneath the space shuttle tile system. And so we had to refine those sensors in order to gather more data to understand if the model of the space shuttle was consistent with what data we were getting back when the actual mission happened. So that was a lot of exciting times. Again, the X-38 project, gosh, I learned so much from working that, getting involved with so many different engineers. One of the things that I learned about engineering, at least for space exploration, is if you become multidisciplined, that's actually a big benefit for the engineer because you get to look at a problem from different directions, not just one direction. And that's something that I didn't realize. I went to school, got my electrical engineering degree, and so my focus was originally in electronics and engineering. But then I started to learn, you have to learn other aspects of it to get the whole picture of when you're working space, especially space projects. So a lot of the projects that I did on shuttle, on X-38, working with SpaceX, working with Boeing, and then also doing some research programs with Jet Propulsion Laboratory, with Langley Research Center. All were beneficial for me to gain more knowledge about how to develop better spacecraft systems.
Well, thank you so much for joining me here today. And it was a pleasure to have you and share all your great stories here.
Well, thank you.